give you an example problem. Suppose Vt is 4 sine t, 4 cosine t, and then square root of t is the velocity of a moving particle whose position at time t equal to 0 is 0, 1, oh actually, sorry, 1, 0, 1, 0, 3. The question is find RT. In other words, given your velocity, figure out the position of the particle. We've done this question many times in Calculus 1. The only difference is now you have to integrate each individual one. Now sometimes the question will be rephrased using ij and k. So sometimes you might see the question posed in the following format. V of t as 4 sine t I plus 4 cosine tj plus square root of tk. And I found out that this ijk notation causes lots of confusion for you. So anytime you see an ijk notation, just change it immediately into the coordinate form. Okay? Just get rid of ij and k and put these into the coordinates, and then work from here. Okay? Yeah. Because I've seen a lot of confusion when you deal with ij and k. All right. So let's solve this. Solution. So what is RT anyways? Because you get VT by differentiating the position. To get RT from VT, what do you have to do? You have to integrate. Let's find the antiderivative of this function. So we have to integrate 4 sine t, 4 cosine t, square root of t dt. And its integral is, integrating sine gives you? Negative cosine. It's negative 4 cosine t. And don't forget your constant, plus c. And then if you integrate cosine, what do you get? 4 sine t plus c. Now, these two c's don't have to be the same, right? They could be different numbers. You could have this as 1 and that as 3, and still when you differentiate 1, it gives you back these, right? So these don't have to be the same. Okay? So let's write C1 and C2. So it could be some constant, another constant, and both of these functions, if you differentiate, you get each of these individually. Right? Finally, to integrate square root of t, you have to first convert this into t to the 1/2 power. Right? And the way you integrate that is to add 1 to the exponent. 1 plus 1/2 is 3 over 2. And put the reciprocal of that number in front, which is 2/3. And then plus c, 3. So that's your RT. The only thing we still need to figure out is these constants. We have to know what these constants are. Okay? Because R of 0 at this point is what? This is, what do you get from here? negative 4 plus C1, comma, C2, comma, C3. Right? Each of these are 0, right? Sine of 0 is 0. When you plug in t equal to 0, you get 0, so you get r of 0 as this. But this is supposed to be what? What is this supposed to equal to?
1, 0, 3.
1, 0, 3, because that's the given point, right? So you put 1, comma, 0, comma, 3. And we now end up with negative 4 plus C1 equals to 1, which gives you C1 as 5. And then C2 should be 0, and C3 should be 3. Just setting them equal to each other for each coordinates. Right? And then we're done. We put them back in, and here's the answer. Answer is r of t has to equal to negative 4 cosine t plus 5, 4 sine t plus nothing, and 2/3 t, so 3 over 2, plus 3. So that's how you do the integrals. Sometimes you might just simply be given a question like the following. You might be just asked to find the integral of 4 sine t I plus 4 cosine t j plus square root of t k dt. If you have a question like this, what would be the answer? It would be just this one. But the purpose of having such a question is for physics questions. If you're given velocity to find the position, you have to do this integral. If you're given acceleration and you have to find the velocity, you have to also do the integral. So there is definitely a need for finding the integral of a vector valued function, and the actual calculation is nothing different from your calculus 1 stuff.